Okay, now we are in chapter 6. Make sure you already go and see up to example 7 on how to use the motion equation and F equal to ma and all the moment equal to all the small moment diagram. Okay. This one is free body diagram, kinematic diagram, kinetic diagram. Okay, today we'll learn something a little bit more. Today we learn about actually moment. When you turn the moment at a certain angle, it will convert into forces also. So this diagram you are familiar. So external forces doesn't care whether the arrow pointing in or out. So there will be external forces. And then as the if the question is in a rigid body, you will see a capital G point, right? And we now only care about what is happening to the center of gravity, the movement of center of gravity, either in a normal direction or tangent direction. So previously, we already established A tangent equal to alpha r, A normal equal to omega squared r. Okay. It's 2. Okay. So this is a normal tangent, normal direction. This one is in the angular dimension. Okay. So this will be the two important equation. But now we focus on center of gravity. Center of gravity. Previously also learned to view in a table, centroid table. Okay, Ixx, Iyy, Izz refer to the table, and moment of inertia equal to I equal to Ig plus md square. So Ig, this one refer to table. The d, if you move somewhere, for example, you move from the G towards a distance of D, and you want to find I at A point, then you need to plus the md square. However, all this information are also inside the table as long as you read the correct Ixx, Iyy, or Izz, or Ix prime, Y prime, and so on. Okay, refer to the same table, right? Okay, so this is just show you, if you see a rigid body, first step, you always convert into free body diagram. And free body diagram is only what you see in a free body diagram is your forces, moment, and weight. Weight component always pointing down. Kinematic diagram, we already look at. For rigid body, your kinetic diagram, remember, is not A, it's not V, but MA. In the rigid body chapter, the kinematics is you look at MA. So you split into tangent, normal direction, especially when there's a rotation. And later you will see Ig alpha. Right? Later you will see Ig alpha. Okay, Ig alpha is rotation moment. Ig alpha is a vector, it's a rotation vector. or you can say is a momentum. So Ig alpha have the same direction as your acceleration alpha. So today, I think the new equation you see today is m moment in the center of gravity. You take I G, which is you read from table, moment of inertia at center of gravity, multiplied by alpha is equal to moment generated by the angular acceleration. Okay, then the rest will be the same as previously, F equal to ma. This one break into normal and tangent direction. Okay, normal tangent direction, so an equal to omega square r, at equal to alpha r. Okay, so this will be the equation for today lah. Okay. Okay, so today we only learn one new things here. All the moment at center of gravity will equal to inertia, moment of inertia at the center of gravity multiplied by the acceleration, angular acceleration, you get the moment. Okay. And you can also use the previous one. Moment in free body diagram equal to all the moment that you refer to the kinetic diagram. So it's, in this case, it O. So what generate moment? If you refer to the diagram here, so there are two moments. One is this one is the blue color, plus this one, MAT. This one don't have, normal don't have, because it's along the axis. Okay, moment always have the F multiplied by the perpendicular distance. So, okay, so if you look at the moment at all these things, so moment at O will equal to RG multiplied by MA, because MA equal to force multiplied by the perpendicular distance. Okay, force multiplied by perpendicular distance, you get moment plus this blue color arrow. This is moment. Okay. So you substitute inside, you can expand the equation. So because this one is tangent direction, AG tangent direction, AT equal to alpha R. So as long as you have the alpha with the radius of the rotation, you can transform the equation from A into R and alpha. So you can eliminate the acceleration terms into R, M, alpha, and Ig. Okay. You factor out the component, you get mr squared plus Ig alpha. Does this one look familiar? I equal to Ig plus md squared. This one actually is your moment of inertia. When you take moment of inertia multiply by alpha, you equal to moment. Okay, so this will be the concept of today. Every time you have moment inertia multiply by alpha, you get moment. So this is the concept. You use this one, mr squared, when there is a force outside from your interest point. Okay. If the O is at G, then you are 0. This one you refer to table. Yeah. So the rest is just the same. Moment equation. moment equation of motion, F equal to ma. So let's apply what we learned. So you have a drum flywheel unbalanced. So unbalanced means when you release from rest, it will rotate at a certain direction. So you have a center of gravity G there and a pin O there. So when the center of mass at the one side, when you let go from the rest, this one will rotate clockwise. Right? So unbalanced, mass is given. So mass is given. When mass is given, translate this 25 kilogram into W. So this draw a W. W equal to mg. Again, don't substitute mg first. Just write capital W equal to mg. Has a radius of gyration. When you're given k, straight away you use equation. Later you see in the solution. If this is released from rest, determine horizontal vertical component of the reaction at pin. This one. Okay. So you draw free body diagram and kinematic diagram. So free body diagram, there are only interest point, two interest point. One is O, one is G. So put in O, and then there is a pin there. So pin always have go up and go to the right component. So you have OX and OY. And there's a G, center of mass, at 0.15 on the right. So you put in there, W point down always. And you have these two components. Okay. Now this O, you can point inside. You can point to the right, no problem. Okay. So this is your estimation only. This is your estimation. Huh? Okay. Then because this one, when this one rotate, G will rotate in a circular motion. Okay, G will rotate in the circular motion. When there's a circular, you can pull out the normal and tangent direction axis. Okay, normal always pointing inside the curve. Tangent always pointing at the tangent direction of the motion. Okay. Kinetic diagram. So kinetic diagram, you put in alpha, omega, MA. Okay. So copy the 2 point. Put in the R. Put in the R distance. Okay. So because of unbalance, you know that this one going to rotate clockwise. So put in the alpha. Okay. So maybe this one a bit too fast for you. So this one will be this one, O and G point. So this one, there will be center of gravity M A in a tangent direction. So this one will equal to M T equal to alpha R. But this one we refer to the center of gravity. And because these things move in the circular motion, so there will be a moment. There will be a moment which is equal to Ig alpha. Okay, so O doesn't move anywhere because it's put in the pin. Yeah, so that's it. Everything is there. So since angular velocity omega 0, so only MA tangent direction is shown. Yeah. This one angular velocity 0 because it released from rest. It released from rest. So this is a new thing for not inside my previous theory slides. So if you're given a gyration k, straight away apply Ig equal to mk square. And this one at center of gyration. Use this one to calculate Ig. When you need Ig, when you want to calculate the m equal to Ig alpha. Okay, so then if you're given the radius of gyration, you don't need to refer to table anymore. Straight away use mk squared. Okay. So now you have free body diagram and kinetic diagram. So we can solve using moment F equal to ma equation to solve for all the unknown, especially OT and ON that you need to solve inside this question. So you substitute, you get your Ig equal to something, right? Remember, use unit SI, kilogram and meter. So your Ig equal to 0.81 kilogram meter square. Okay. Why? One reason also kg is this radius of gyration is given because inside the table there's no shape, there's no individual shape to allow you to remove this section. So you use a radius of gyration 0.18 to calculate Ig. In the table, there's no one single shape that you can use. Okay, we use equation of motion, these three equations, mg equal to I alpha, Fn and Ft, Fn equal to ma in the normal direction. Change the A into omega form. At equal to F equal to mat equal to alpha r. So on the top, mg refer to the left-hand side free body diagram. So you refer to the g, you put your hand here, you only see two forces, and On do not generate moment. You put here, this one generate moment clockwise, anti-clockwise. Okay, On do not generate this one. So anti-clockwise positive equal to Ig, you already calculate just now. Now you can find alpha. Okay, so first equation tell you what is alpha. So once you find alpha, substitute here, you manage to find OT. Okay, so this one equals 0 because omega will be 0. So most of the time, sometimes we will just tell you in the question, omega equal to 0. Angular velocity equals 0. Then the rest is just solving F equal to ma for tangent direction. So in this way, OT negative is because you assume go down negative, go down positive. Okay, in this case, why negative? But you assume go up positive also, but it depends on your diagram. Because tangent direction go this way. Because you rotate clockwise, tangent direction point down. Okay, so that's why positive go down in tangent direction. So tangent negative go down, OT negative, W positive. This is from free body diagram. Another side, you refer to the kinetic diagram. Right hand side, refer to kinetic diagram. So kinetic diagram, M alpha 0.5, remember, okay. So you substitute solving, you get alpha. So take alpha from here, substitute here, substitute m. You know how to calculate W. You can find OT. Okay, reference answer for your OT will be 144.7 Newton. Okay. This is another method. Moment can also sum about O in order to eliminate ON and therefore obtain direct solution of alpha. So you can use another equation. So this one is using 3 equation. You solve for alpha. Another one, you use moment equation. Moment referring to free body diagram equal to moment referring to kinetic diagram. So you put your moment at O. Left hand side, you only see W multiplied by 0.15 clockwise. So you get negative because you assume anti-clockwise positive equal to here. Here you have 2 moment. IG alpha, 1 moment. Purple color is moment. M alpha R is force. Force multiplied by perpendicular distance, you get moment. So M alpha RG multiplied by RG plus IG alpha. Again, you should follow the direction. If you take anti-clockwise negative, so this one negative, this one negative also. Okay. So while looking at the working, it actually clockwise positive. If you look at this one, this one positive, positive, positive means your moment, there's a wrong notation here, means you take positive as clockwise as a positive. So if you look at this one, so wrong notation if you use the purple color answer. You put in the value, W you have, you can calculate. IG, you can calculate, IG equal to mk square. M, you have, alpha, you don't know. R, you have, R, you have. So you have 2 alpha here. So you plus the value, right? So another solution is MO equal to I alpha, also same. So both are, this one is one set to calculate alpha, or you can use another equation, MO equal to IO alpha, also get the same answer, same equation. Okay, there are 2 methods. Either you are familiar with this one, you can use this one, or you want to use this one, also can. You arrive at the same equation. Then solve using F equal to MA in normal and tangent direction. Okay. So another application, you see this one. So there's a pin, there's a rod given a mass, have an angular velocity omega. Determine angular acceleration and horizontal vertical component of the reaction at pin of the rod at that instant. So this one got a pin. So pin, no moment at this one. So, but you have a vertical and horizontal OX and OY here. And you have an external moment, 60 Newton, and you have an omega 5 radian per second. So every time you're given a object, always go and find where is the capital G, center of mass in the object. So go there and find 3 meter is actually in the center of the rod. So put a dot in the middle of the object, then label as G, and then draw W go down. Yeah. So free body diagram. Again, free body diagram, there should be a body, no dot, no line. You put in O will be OX, OY. Remember, put in the center of gravity or center of mass. So there will be in this case, you can put X and Y, or because you know that this one is rotate in a circular motion, So we can put away in the tangent and normal direction. Okay, this one initially when you do your working, you can put t as x, t as y, n as x. But because this one is rotating usually in the circular motion, so t will be in tangent motion, n will be in the normal direction. Okay, then you follow the motion. You need to tell where is your positive direction of tangent, where is the positive direction of normal. So if you draw a curve of the center of mass here, so normal will be this way, tangent will be this way. Just follow the motion for the normal and tangent axis. Okay, so put in the external forces that you know. Okay, so don't put in omega in the free body diagram. Omega is in the kinetic diagram. So draw the same object, and you only see is in the motion. So you look at center of mass, where the center of mass go. So center of mass, if you stand here, you look at G will rotate in the circular motion. So circular motion, go down is tangent direction. Okay. Tangent is alpha r. A tangent is alpha r. So MA, MA change to angular term. Then pointing to the normal or center of the curve will be MAN. So AN equal to omega square r. Okay, MA, MA. So rigid body, free body diagram and kinetic diagram, you need to write MA and not only A or V. In chapter 1, 2, 3, particle, yes, you can still write A and V, but when it comes to rigid body, in your kinetic diagram, we are expecting you to write MA already, for the forces. Okay, then the rest you just add inside there. So since this one moving, there will be a moment because of inertia. So Ig alpha is your moment. There's a moment make it the thing turning. And we just follow the motion. We just follow the omega motion. Okay, so once you have complete the free body diagram and kinematic diagram, again, solving these three equations. All the moment equal to Ig alpha and F equal to ma. Depend on question. F equal to ma usually will be in circular motion. So you break F equal to ma into normal and tangent direction. Convert the A into angular term. An equal to omega square. At equal to alpha r. Okay. If you're given radius of gyration, you just write Ig equal to mk square. You get 1 mark for this equation. Then you substitute, you get your Ig, then substitute back, find the alpha. Once you have alpha, you can solve any missing parameter in the F equal to ma equation. Okay, same presentation. All the moment equal to Ig alpha, Fn equal to ma n, Ft equal to mag t. Then you solve. Then you solve. So again, the first equation here you can solve using all the moment at G equal to all the moment in kinetic diagram. There are two methods. Two methods. So you put in all the value. In this case, this is a rod, so refer to table. Your rod at the center of G will be half, not half, 1 over 12 ml square, if you refer to the table. And you're referring to the center of gravity, meaning if you read the table, it's reading from I-XX, I-YY, pointing at the center of mass. Okay? So this one, refer to this one. So because the G at the center, so you read IXX, IYY equation, this one, for your IG. Okay. So this just explaining why suddenly there's a half, 1/12 ml squared there. Okay. So here, OT you don't know, alpha you don't know. Okay. So you continue to solve using Fn equal to m omega square r. Okay. So in the normal direction is to the left positive. Then m omega square is given, omega is given 5. R is 1.5. Okay, because this is a rod, 3 meter, center of mass always at the center of the object, half length of the object. So here, you have the mass. So ON you can find already. Okay. FT also substitute, go down positive, tangent go down positive. So in your free body diagram, OT point out. So there's a negative equal. Remember there's a W. Refer to free body diagram. Forces, you have two forces here. So OT go up negative, W go down positive. You're following the tangent direction, go down. So M alpha R, you know. Okay. So you have this equation and this equation. You can solve simultaneous equation. OT, OT. W you can substitute mg. Then this one got alpha. So you're solving two simultaneous equation. Then after you get, substitute back here. No, ON already have. Right? Okay, so your reference answer for alpha will be 5.9 radian over second square. OT equal to 19.05 Newton. Any question on the steps? The step, yes. This one? Hold on. OT, it should be 1.5, not 0.15. Typo error in my slides. L will be 3. L will be 3. So it should be 1.5. Here should be 1.5, not 0.15. Yeah, okay. Thanks for pointing out. So typo error, not 0.15, it should be 1.5 meter. Same with this one. Same also, this one also wrong. Should be 1.5. Okay, so if this example 9 come out in your assignment, please make correction. Please make correction. If you write 0.15 in your answer for assignment, you won't get full mark for that particular question. Okay. So ON you have, ON is 750 Newton. Okay, another one will be same, another method of solving where you use all the moment equal to moment in the kinetic diagram. That's why we use MK in the kinetic diagram here. Okay, you arriving the same equation as this one, this one. You arrive same equation as this one. Okay, there are two ways of finding moment. Okay, so this is just solving, you still arrive at the same equation. Yes. Final, you are free to use anyone, unless the question purposely asks you to use one of the solution. But usually we give you freedom to answer in either one. Okay. Yeah. So usually the question will ask you to find I in the question. But if you're not sure whether you I correct or not, then you use this one. Oh. You're not sure. Okay, both arrive at the same answer. It's just a different approach to solution. You usually anti-clockwise is negative. Anti-clockwise is positive usually. This one is it correct? This one is yeah, actually it should be clockwise. So the symbol is wrong actually. Okay. Standard will be anti-clockwise positive, but as you see my steps, I always follow the motion. If the motion is clockwise, I will just follow clockwise positive. So it eliminates all the negative sign. You need to say in your solution which one is positive. You need to stick to one direction. If like question one, you already like your moment clockwise is positive, then you do positive. So it depends on question. Depends on question. My advice is if you scared, then you all the anti-clockwise positive. If you really like, okay, you don't know whether which case is positive, then you just in the general case, you just use anti-clockwise as positive. You still arrive at the same answer. Mean this one negative, 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 negative. You still remove all the negative when you rearrange the equation. The challenges part is the arrowhead lah. The arrowhead, you don't know whether it's point up, point down. Okay. W sure point down. This one you follow the logic thinking. Where will it swing? Okay. This one, IG, you need to guess. Where is the direction of arrow? This one swing down already. So you follow the logic direction. Okay. Number 10, you just have a look into it. See if you're able to follow along the steps. Actually, not as hard as you think. At the end, you're still using the all of mass equal to IG alpha, or another way is using moment in the free body diagram equal to moment in the kinetic diagram. And then F equal to MA. Change the A into normal tangent direction. Okay, so there's a drum in this case. A drum shown in the figure have mass 60 kilogram and radius of gyration is given. When every time you see radius of gyration, straight away write IG equal to MK square. You get 1 mark for this equation. A chord is ignore mass what around the outside of the drum. Attach a block having mass of 20 kilogram. If block is released, determine the drum angular acceleration. This is angular acceleration, which is alpha. So alpha, when you find the moment, you find the IG, you straight away find the answer. Okay, so you need to draw two diagrams. One is free body diagram, one is kinetic diagram. So forces at the pin always up and to the right or to the left, it depends, whichever you like. But usually go up positive, go up. There will be OX, OY, go up, OX to the left or to the right, depend. Okay, so this one, when you release from rest, so this drum will rotate what? Anti-clockwise, right? You can imagine, right? If a drum drop, this will rotate anticlockwise. So when there's a angular circulation, angular motion, you can write W and also alpha. Okay. And then there's a drum here. So no matter the shape of the drum, this is a circular body. Circular body A will be pointing down. The tension will be at the tangent of the point A here. So if you can change the force of the tangent cable here equal to mg, this one. Okay, there are two solutions. I show you the two. So if you break this into two objects, you have W. Remember W, this one one of the careless mistakes in test. As you go into rigid body, most of the time you will forget this one. Okay, so W equal to mg, OX, OY, and then there's a tangent tension cable go down. So you want to find the tension cable equal to mg, right? You can leave out this one if you want. Okay, then y and x. Positive to the right, positive going up. And then you know that the drum is rotate anti-clockwise. So this is alpha. A is going down, positive, at tangent direction, or following the cable. Okay, so this is a counterclockwise angular alpha. Okay, solution one, you just use the formula Ig equal to mkg square. So this one, you just replace the g as O, because or in your diagram, you can write g here lah. If you want to use Ig equal to kg. So go to your free body diagram, write your g here. So m you have, k you have, your IO equal to 3 point something kilogram meter square. Once you have your IO, use the three motion equation. F equal to ma, motion equal to moment equal to I alpha. Okay. So you can use x and y if you want. But here I'll show you the solution for m. F equal to ma, F equal to may. So if you apply m equal to I alpha, m at the free body diagram, you have t and your moment at O. So OY gone, OX gone, W gone. You only see t motion or t moment. So in this case, if you in this case is anti-clockwise, positive, so t should be negative, right? But again, I'm following the motion of the object, clockwise positive. So again, it's a typo error in my slide here. It should not be labeled as anti-clockwise. I should label positive clockwise, positive clockwise, anti-clockwise. But I hope you get the idea lah. So on the left will be moment, referring to free body diagram. On the right will be referring to your I alpha. I you just find just now. Okay, so the first set moment equation, you arrive at T and alpha. So actually you know how to find T already. So you have T value, you have your alpha already. So F equal to MA, X and Y. So in the x direction or in the normal direction, because these do not move, so this one you cannot solve, all the force equals 0. Then y, you have t go down positive, w, it should be negative, negative t, negative, sorry, it should be positive t, because go down positive, w should be positive, not negative. Typo error in my slides, should be positive w. Minus a, it should be, oh, okay. If you're following this one, your t should be negative, w should be negative, m, a, your a should be negative. Okay, so typo error in my solution here. If you're following this y go up positive, then your t should be negative. So a equal to alpha r, at equal to alpha r, a in tangent direction. So your a alpha is 11.3 radian per second square in the anti-clockwise direction. Then you can find acceleration, because this question do not ask you about acceleration, it asks you about angular acceleration. So it's an option to find acceleration. Of course, final exam question will ask you to find acceleration. Okay. Tangent is just applying back here. Once you find your a, substitute back here, you'll find your t. Okay, so another method is you combine as a one system. As you can see, I eliminate the t by using w straight away. I combine the system as one system. Means the rope and the drum are the object here as one body, and straight away I use W2 in my free body diagram. So there will be I alpha in my moment of this object, and MA pull down, M2A pull down. So just a reminder, don't put your MA in the free body diagram. MA is in the kinetic diagram. So same, if you use the same, A equal to alpha R, because A rotate in the tangent direction. So AT equal to alpha R. Then you apply the moment in the free body diagram equal to moment in the kinetic diagram at the point O. So you will have, you will close here. This one will be W multiplied by 0.4 distance here equal to I alpha plus this one plus MA multiplied by the radius. This is a force multiplied by perpendicular distance FD. You get moment. Your D is R. Convert this one, A equal to tangent direction, AT equal to alpha R. Then you solve. Okay, you still get 11.3 radian per second. There are two ways of solving. So you can either use this one or this one. So all the moment equal to all the moment in kinetic. So, okay. This one is what you already know. What you already know. So if you're given a body, you can draw in the free body diagram and kinetic diagram. So it just introduce you again, M equal to I alpha, F equal to MA, and so on. Okay. So same, it gives you two set of solution. The mass, the moment. One is Ig alpha, one is kinetic and free body diagram moment. There are two set of solution. Both arrive at the same answer. Okay, another one. 2 more minutes, then we call it a day. Another one is we like to use IC point, instantaneous center of zero velocity IC. So in this case, if your round body rotate in the same in the anti-clockwise direction, central of mass move to the left. We can solve by using m equal to I alpha also. But in this case, our IC will be the radius. It's the same thing. So this is just a application of what you see from the diagram, convert into free body diagram. There's a contact force. There's a pin here. Pin will be GY, GX, W of the wheel, friction, normal contact force. Okay, so this one will be free body diagram. This will be the kinetic diagram. So force again, MAG, this one will be in the kinetic diagram. And every time you draw kinetic diagram, there will be alpha. Every time there's an alpha, there's an initial effect. Ig alpha, you'll get moment. Okay, so this one is just repeating what we learned just now. You are given a radius of gyration 0.35. So again, when you see radius of gyration, write Ig equal to mk square. You have a mass. The chord is you can ignore. So you have two radius there. Okay. You see the diagram, W, and there's a tension at the convert all the cable into forces and reference to A. So their tension at A, tension at the radius 0.2 meter. Remember the weight go down for free body diagram. And what do you think if you pull the 100 Newton? The direction of rotation is what? Will be clockwise. You pull this one, this drum will rotate clockwise. So kinetic diagram is what you estimate the motion. Okay, the center of gravity will move up. If you look at center of gravity, it will move up. Acceleration here will move up, MAG at the center of gravity. And there's a rotation, IG alpha. Once you had able to draw free body diagram and kinetic diagram, the rest is just follow this one. Mg equal to I alpha, F equal to MA. Convert A and N into normal tangent direction. Then, or you can find moment in the free body diagram or moment in the kinetic diagram. You just substitute, see what information you have, substitute. Then Ig is given, K is given, so Ig equal to Mk. Substitute back here, you find your alpha. Okay, you see that? So the step is always same. Always same. Solution 2, you arrive at the same answer. Solution 3, by using IC, M equal to IC, or another method here, all the moment in IC will equal to IC alpha. Again, how to draw IC? IC is always 90 degree This is your IC, RIC, and this is the force, the velocity or this one. Okay, this one will be the force. Force at the center of gravity, or MA. So you put in there, you still get the same answer. 13, your homework, go and find, go and read. 14, go and read. Okay. 14, okay, go and read. We conclude this chapter. Okay, so see you guys on Wednesday. Sign your attendance, Sign your attendance before you go.